Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 2, Electrostatic Potential and Capacitance. But today is not problem solving session, problem questionnaire session. That is, 7 questions will be sprinkled in this session, and in next session we will solve the solution for this question. Let's move to question number 1. Two charged spherical conductors of radii R1 and R2 are connected by a wire. Then the ratio of surface charge densities of the spheres sigma 1 by sigma 2 is dash. Option A, R1 by R2. B option, R2 by R1. C option, square root of R1 by R2. D option, square root of R2 by R1. Here, what is sigma? Sigma is the surface charge density. By knowing the relation between surface charge density and radius, or knowing the formula about the surface charge density, you are able to find the solution of this question. Let's move to question number 2. A short electric dipole has a dipole moment 16 into 10 power minus 9 cm. What is cm? Coulomb into meter. The electric potential due to the dipole of a point at a distance of 0.6 meter from the center of the dipole, situated on a line making an angle of 60 degree with the dipole axis is dash. Option A, 200 volt. B option, 400 volt. C option, 0. D option, 50 volt. Here what you want to find? You want to find the electric potential due to dipole. And from the given data, that is dipole moment is given and degree theta is given, distance is given. So by knowing the formula of electric potential due to dipole, you are able to find the solution of this question. Let's move to question number. If potential in volt in a region is expressed as V of x comma y comma z equal to 6xy minus y plus 2yz. Electric field in Newton per coulomb at point 1 comma 1 comma 0 is dash. Option A, minus 3i cap plus 5j cap plus 3k cap. B option, minus 6i cap plus 5j cap plus 2k cap. C option, minus 2i cap plus 3j cap plus k cap. D option, minus 6i cap plus 9j cap plus k cap. Here you want to find the electric field. You should know the relationship between electric field with respect to electric potential. By knowing the relationship, you can apply this formula and simplify this question. Let's move to question number 4. 4-point charges minus Q, 2Q and capital Q are placed at one at each corner of the square. The relation between Q and Q for which the potential at the center of the square is 0 is dash. Option A, capital Q equal to minus small q. B option, capital Q equal to 1 by Q. C option, capital Q equal to small q. D option, capital Q equal to minus 1 by Q. Here you should know the relation between, that is, point charges means that is, you should know the relation between the electric potential with the position. That is R or R1 or D or X, whatever. By knowing the relationship and by applying this to square symmetry, you are able to find the solution for this question. Let's move to question number 5. A parallel plate air capacitor has capacity C, capital C. Distance of separation between plates is small d. And potential difference, capital V, is applied between the plates. Force of attraction between the plates of the parallel plate air capacitor is dash. A option, 3 Newton per coulomb. B option, 4 Newton per coulomb. C option, 5 Newton per coulomb. D option, 20 Newton per coulomb. Here you should find the formula for parallel capacitance. There is a C value for parallel plate capacitor and relationship between force of attraction, V value and distance value. You are able to find a solution for this question. Let's move to question number 6. The capacitance of a parallel plate capacitor with air as a medium is 6 microfarad. With the interaction of a dielectric medium, the capacitance becomes 30 microfarad. The permittivity of the medium is dash. A option, 1.77 into 10 power minus 12 c square n power minus 1 m power minus 2. B option, 0.44 into 10 power minus 10. C option, 5.00 C square n power minus 1 m power minus 2. D option 0.44 into 10 power minus 13 C square n power minus 1 m power minus 2. Here you should know the formula for parallel plate capacitor in air medium and also in the dielectric medium. And by finding the ratio, you will get some value, and you should know the relationship between permittivity of the medium and permittivity of the free space or vacuum, and permittivity, that is relative permittivity or dielectric constant. By knowing this formula, you are able to derive and solve this solution. Let's move to last question. Three capacitors each of capacitance C and of breakdown voltage V are joined in series. The capacitance and breakdown voltage of the combination will be dash. That is here option A C by 3, V by 3. B option 3C, V by 3. C option C by 3, 3V. D option 3C, 3V. Here you should know the relationship between capacitance of the capacitor when it is connected in series with respect to voltage. When it is connected in series, what happens the voltage? By knowing that idea, you will derive the solution for this question. Okay, thank you. In next session, we will solve the solution for this question. Thank you.